Okay, what you need to know already is you have learned about all the differentiation rules, including chain rule. You have product rules, quotient rule, okay, and also you have learned about implicit function, differentiation of implicit function, and of course you have to know what the problems from questions given. Okay, so in this topic, you have to solve problems concerning rates and change, including related rates. Okay, a related rates problem is a word problem in which two quantities are identified and are related in some way that's usually not stated. The rate of change of one such quantity and some other information are given, and the rate of change of the other quantity is required. So you have to follow all the general tips for how to solve a word problem. A change from words to symbol. Identify the existing relation between the two key quantities. And also look up the correct formulas such as formula of volume, formula of area. Alright, so the first example. An ice cube with a 10 centimeter side is melting, so that its volume decreases at 12 centimeter cube per minute. How fast is its surface area changing? Okay, so let's change from words to symbol. Okay, ice cube is cubic, okay, where all the sides are 10 centimeter. So 12 is dV dt, rate of volume. Okay, rate of volume decreases at 12, so means dV dt is 12. Okay, so what you need to find out is how fast is surface area changing, means that you have to find dA dt. Okay, let's illustrate the ice cube like this. Okay, all the sides are S. Alright, so there are several quantities associated with this cube. There are two quantities, surface area, A, and V for volume, and let S as a side. Now, we are going to relate these two key quantities, volume and area, surface area. Alright, so first, from the questions given, we need to find out the rate of area, surface area. Okay, the rate of surface area melting. So it means that we no need a volume, or we don't have any information about volume. So I express S in terms of V, then we use it to substitute into formula of surface area. Okay, now surface area A in terms of V. Alright, so we use a method of implicit function, differentiation. Okay, so now we use it, formula of A in terms of V, find out or differentiate surface area with respect to time. Means that we differentiate both sides with respect to time. So we find out dA dt. Okay, and this is implicit function. Differentiate V with respect to t. So we have dV dt at the back. Alright, so now we have to substitute V and any related information given by the questions. Okay, so we have side, all side is 10 and dV dt is negative 12. Alright, here, so why negative here? Okay, because from the question, the volume decreases. Decreases means dV dt is negative. Alright, so substitute all the values S and dV dt into dA dt. Alright, so take note, V is S cube and S is 10. So means that here we got 10 cube. Okay, and we have dV dt negative 12 and the answer will be negative 4.8. Okay, so for the conclusion, therefore the surface area is decreasing at a rate of 4.8 centimeter cube per minute. Alright, next question. Okay, we have example of height of a right circular cone is increasing at a rate of 1.5 centimeter per second, while its volume is increasing at a rate of 2 centimeter cube per second. How fast is the radius of the base of the cone changing when the radius is 6 centimeter and the height is 8 centimeter? Okay, so you have to convert from words to symbol. Okay, alright. So here we have three variables: volume, radius, height. So we use V, R, and H. Okay, and we got information of 1.5. 1.5 is rate of height. So we can use symbol dH/dt, dH over dt. And 2 is a rate of volume. So we change it to dV dt. Alright, so what we are going to find out is how fast radius changing means that we find out rate of change of radius, dr dt. So we are going to find dr dt. Alright, so here are the informations we have. So we have to substitute the value of r and h, and from the formula of volume, 1 over 3 pi r square h. Okay, we differentiate this implicit function, means that we have to apply product rule. So dv dt, okay, so here is the product rule we have applied already. Okay, we apply the product rule. So this is u, this is dv dt plus v du dt. Okay, alright. So next, substitute all the value we have. Okay, so here we have 2 and 1.5, and substitute radius and height. So dv dt is negative 0.5426. So this is the rate of radius changing. Okay, negative 0.5426. That means the rate is decreased. Okay, another example, and this time we try to solve it use the chain rule. Okay, before this we use implicit function, but now we will use chain rule. Okay, so we have a container in the shape of hollow cone of semi-vertical angle 30 degrees is held with its vertex pointing downwards. Water is poured into the cone at the rate of 5 centimeter cube per second. Find the rate at which the depth of water in the cone is increasing when this depth is 10 cm. Okay. So for the variable here, we have depth or height. Okay, and we use the variable x, and we have radius r. And also we got the information about dv dt. 5 is dv dt. Okay, 5 is rate of volume. So dv dt. Alright, so before that, okay, from we must try to illustrate. Okay, because there is no diagram here, so we try to sketch the diagram. Okay, so we have the height or depth. So we use x as a variable, and we have radius r, and also got angle 30 degrees there. So from this information we can have radius in terms of x. Okay, so for tangent 30 degrees we find out the value, and we got r in terms of x over sec 3. Right, next, because this is cone and we have information about rate of volume. So what is the formula of volume of cone? 1 over 3 pi r square h. So H we noted as X, okay, X here, and R, okay, from the question we have no information about the radius, so we try to express radius in terms of X. Okay, so, means that now we substitute the R, okay, substitute the radius, and now the volume is in terms of X only. Okay, so what we have? Okay, now we have volume equal to 1 over 9 pi x cube. Alright, so what's next? We will use this chain rule. dv dt equal to dv dx dx dt. Okay, so first we find out or we differentiate v in terms of x. So we have dv dx. Alright, so dv dx is 1 over 3 pi x squared. Okay, so dv dx we have, and then we also have the information of dv dt from the question. dv dt is the rate of volume. Okay, so from the question, dv dt is 5. Okay, this is dv dx in terms of x, and this is the chain rule. So substitute all the information we have, and also the depth given is 10. So x is 10, so substitute into the function, into dx dt. So what we have is the rate of increase of depth when depth is 10 is 3 over 20 pi centimeter per second. So, if you are using Oxford book, okay, you can have the checkpoint 8.12 question number 1 until number 5 for your enhancements exercise.